Hello everyone and welcome to episode number 12 of the DDoS Talks. My name is Ivan, I'm support officer at the Luxembourg Digital Innovation Hub. And for today's topic we have information security and DDoS incident management. So please, therefore, we can welcome our two speakers from the Luxembourg House of Cybersecurity. First, we have Anita Arul Rajakumar, Cybersecurity Specialist at NC3, the National Cybersecurity Competence Center. And we have Gerard Wagner, Operator at Circle, the Computer Incident Response Center. So Anita will shortly introduce us to the cybersecurity services of the DIH, and Gerard Wagner will jump into the main topic. And just before we begin, I would like to put your attention on the question tab in the chat. Feel free to drop your question there anytime, and we will address them at the end of the session. So I think we are ready to start, and I give the word to Anita. Welcome, Anita. Hello.
Thank you, Ivan. Yes. Welcome, everybody. Today, I'll briefly introduce the L-DIH and the cybersecurity services that we have. For most of the audience who have been regularly attending the webinars already know about this. So the Digital Innovation Hub, the objective is to help manufacturing companies to bring up the digital maturity. So we are across EU. There are 254 centers, and the one in Luxembourg is called L-DIH. So we run awareness programs, also conduct industrial meetup awareness sessions, both on funding and technical topics. And part of the services, we have a couple of assessments for digital maturity, cybersecurity, digital skills. We also have services on technology testing and awareness, both on funding and cybersecurity. So for the cybersecurity services, we have two of them in this project. So one is light cybersecurity assessment. This is a small questionnaire of 28 questions. It takes about half an hour to complete. This will give you an idea of your organization's maturity, and it also comes with recommendations. Once you complete the test, you will be able to download this report, and you can go ahead and implement these recommendations to improve your cybersecurity maturity. The second part is called Cyber Value Pack, where we have three services combined together. One starts with the most important cybersecurity awareness for the entire team. The second service that we have here is Room 42, which is a simulation of cyber attack. So you can include your team and the C-suite to come and immerse themselves in the simulated environment. And the third service is the testing platform, which helps you validate your applications and website. And for manufacturing sector, you can also do an IoT firmware testing part of this. So now, I've also added the links on the presentation that could be used. So you could visit our website. And if you have any questions, please feel free to write back to us on the contact. Now I can hand over to our next speaker from Circle, Gerard.
opportunity to be here. I'm just putting back the presentation. My name is Gérard Wagner. I'm working since 2011 at the Computer Incident Response Team. So in fact, we are acting like the firefighters when there are incidents, and for the private sector, then they can call us, and then we help them to recover from the incidents. So we are mainly contacted by technical teams. So when incidents happens, then and we have to do technical actions, to recover from the incidents. So this is also a nice opportunity for presenting another project that we have. It's called the Next Generation Security Operating Training Infrastructure. This is because we noticed that during incidents, when there is a lot of stress, technical teams sometimes do mistakes. So it's good to confront them with real attacks on real infrastructure, but in a controlled environment. That is the NGSOT platform, so that that they can get used to the attacks. The stress and all the themes around the real incidents. So in this presentation, what I wanted to, there were some objectives that were announced. So I'm an incident responder, so I try to simplify and do the presentation as less technical as possible. But I wanted still to put a focus on to understand how denial of service attacks works, because the better you understand how they work, the better you can assess the impact on your infrastructure. Then I will briefly present some countermeasures that you can take. And in the last part, I will focus on the management part, where we, for instance, as incident responder, we saw a lot of items that can be improved, for instance, during incidents. So then we listed them together. And the last part, it's this is you can, where I will provide you some contact details where you can send your technical teams to prepare themselves to handle incidents and to be confronted with real attackers and taking actions on real data. So this is the operational infrastructure that we have. So we have so that means that technical teams, they can contact us. So they do what we do is we do then an appointment where the team, they can then join. And this is they can all join virtually this infrastructure. So then we set up some calls where they can then join virtually the infrastructure. And then on this infrastructure, we will have then typical tools that you will find in real SOC environment. And then the audience, they can then use these tools, play with real data. For instance, it's real data and also real-time data, where they can play with it, and then to get them familiar with SOC operations, and then to better fight the incidents. Why is this important? It's because during many incidents, we noticed that there is a lack of data, so a lack of visibility on the technical infrastructure. And then, of course, when you lack data, you cannot take the right decision. So the incidents where we did some technical support, it was, so the companies that handled them best were the companies that had a lot of technical data, a lot of telemetry of their networks, so that they could also do identify exactly which kind of incident they had, and also then to take the right measures. And for instance, this technical data, you can collect them in your infrastructure. So that we recommend it's to collect as much as log files as possible, to also collect network traffic, even in peacetime, because then you see how your network traffic looks like. And also on the different hosts, to have some telemetry running to collect also data on the different hosts, that you see, okay, for instance, if there is a host infected, what is the infected host doing? So if you can see what is the host is doing, that's really important. Then from the other point of view, that is what we do, but also other commercial SOCs, CSIRTs, they are doing that. So we are so on the one hand, you can collect the data from your infrastructure, and for the other hand, you collect the data from outside your infrastructure. And this is, for instance, the collection of malware samples that are used, configuration files of these malware samples for doing denial of service attack. And you can also then reverse engineer. We do the reverse engineering of the malware samples to see exactly how they work. And then when there are some teams that go even further, so where you have where you monitor the different activities of the attackers. For that, there is a project that is called IEL framework that can be used. So where you can follow the discussion between the different attacker groups, how they coordinate to attack the different victims. So also from there, you can get a lot of information. Also how to protect your infrastructure and how to react properly. Then, of course, what we do is we have a large training platform where we share different threat intelligence and block lists. So the data analysis, I will go quick over it, but what is really important, you need to have as raw data as possible, as much as raw data as possible, but afterwards you have to be able to understand it and to interpret it. So I'll give here the example. So you have data where you have different packets. So this is kind of network traffic, then you have packets, you have different protocol layers, and afterwards you have botnet commands. So if you do this analysis of all this data, so okay, there is an example that how there are even tools for doing it. You know how afterwards how the bot is working. I will now jump to the topic of denial of service attack, especially the distributed denial of service attack. So a denial of service attack is an attack that is often used against victims, as it's an easy way of sabotage. And how does it work? So they just overwhelm the service, so that afterwards your service cannot distinguish between legitimate customers and attacking customers, and then the service goes down. It's like if all the people they coordinate to send people to the bakery, then afterwards there will be a huge queue, and if they are legitimate customers or customers that don't buy anything, the legitimate customers, they cannot buy anything because all the other customers are blocking the queue. And how the attacker is it doing it? So in this example, he's abusing equipment from third party. So that are the equipment that is going into the queues to block, for instance, and then he's abusing this equipment for sending different traffic to this to the victim, and and then to saturate the queue, and then that the service cannot be delivered anymore. So that there are different types of attacks. For instance, the volumetric attacks. So these are flooding the bandwidth. Then we have protocol attacks that exploit some items on the protocol, then also some application layer attacks. And how do you see that you have denial of service attack? It's the service is not available anymore. And when you do the network monitoring, you see different spikes of traffic spikes and many sources, many IP addresses want to connect your services, and your service is reacting slower. And until the point where there is a timeout because the service cannot reply in the time that it should reply. Here is a quick example of how it works. Since more than 10 years, there are some malware that is called, it's a Mirai GovKit variant. So what they do is, so what the attacker does is, the attacker hijacked some command and control servers. These are the CNC servers. Then they have also some servers and loaders, for instance, to push new. So the server is, for instance, distributing new victims, also for searching for new victims. The loader, they are pushing new configuration to different bots, and then the bots, all the bots they find, all the devices they find, they try to attack down the victim. So when you do this protocol dissection, for instance, here I give an example of the a bot that is called QBot. That's also often used by attackers. So then we can extract different commands that they are using, and then based on the commands that we find, we can then propose first confirm which kind of bot it is when you have a denial of service attack, but under the assumption you have the data, for instance, network traffic, and then also to which countermeasures you can take. Here is an example of a denial of service. So we had a denial of service attack on our own infrastructure. So this one, so the attacker, they target our public available website, circle.lu, that was at this IP address. And then in the configuration, you see that, for instance, they they targeted a different endpoint of the websites, and then you can either shut them down or reroute them, and you can then take some actions against them. And then, for instance, this is the attacker groups. So there's a dedicated software that is called IEL project. So what is it doing? It joins the different chat rooms of the different attacker groups, then afterwards archives the messages and do some Yara matching on it. So I recommend to go to this open source project. It's on IEL project. You have the software and also the training how to use it if you want to do these kind of activities. Then also there are some commercial DDoS services. They are mainly offered in the darknet because it gives more anonymity to the guys selling the services. So how does it work? So you can go to these darknet addresses, these onion addresses. This one is a very old one. And then afterwards you can then pay them for, you pay them, and then they do then denial of service attack of your victim that you choose. And that's why they are also in the darknet, because in many countries these services are illegal. But then for the denial of service attack, so many people, they think, okay, I'm not targeted by denial of service attack because why should cyber threat actors target me because I'm a small SME producing some items? But what happened a lot is that because the attacker groups that are doing denial of service attack, they need resources. So what we see a lot is, for instance, video cameras. So if you have a production plant with video cameras, they have very nice bandwidth. So what they do is this, for instance, this Mirai variant, it's compromising the brand of video cameras. And then the video camera is not, it's still recording the video stream, but in the same time, it is attacking, for instance, a school. For instance, if the threat actors decided to attack a school, then they attack the website of a school. And so that means that then, in your case, then your video camera will contribute an attack against the school. Then, of course, you also notice it because the video, in this case, the video stream, it's getting slow, or the video stream is not, your camera is not working anymore. But yeah, these are the facts. And how does it work? So, for instance, here is an example where that was taken 2 days ago. So they are constantly, so the attacker groups, they are constantly scanning the entire internet and trying to push this DDoS malware on the video camera. So in this example, it is an indicator. So what they really like to do, it's they want to exploit known backdoors of implemented by the hardware vendors. Unfortunately, in the IoT and OT world, this is still often the case. So you have PLC systems, you have routers, etc., where the vendor said, "Oh, you know what? For the remote management, we will put hard-coded username and password inside." Obviously, what happens is the attackers, there are some attacker groups that are reversing this firmware, they find the backdoor, and then they exploit it. So the example before, it was an exploitation of a hard-coded backdoor. And the first backdoors that we found, for instance, was in cable modems, so in 2014, but even almost today, for instance, or the recent vulnerabilities 10 years later, for instance, in the PLC, for instance, so some vendors are still implementing backdoors in their devices, and then obviously they are then exploited for doing denial of service attack. But so normally we recommend since more than 20 years that security through obscurity, you should not do it, because if you do reverse engineering, you find the backdoors, but still a lot of vendors are doing it. And so then if you want, in the screen before, you saw a lot of vendors. So if you have equipment in your manufacturing chain, you have routers for doing the network segregation. If you have all kind of equipment, we have a tool that is called vulnerability.circle.lu, where you can enter the different information on the tools you get, and you can get the vulnerabilities. So then you can see, for instance, okay, the router that I have there, it has a hard-coded backdoor, so maybe I have to replace it with something else, or I need it to put somewhere else where the backdoor is not exposed. So here is again the explanation on how it works. If you unintentionally contribute to a denial of service attack, so that means that in this case, the attack is not against your infrastructure, but it's abusing your infrastructure to attack someone else. So in the first step, a denial of service bot is installed. Then the bot is instructed to target the school, for instance, the target, for instance, the school. And then what happened then is the school, they could ask for help. So the school says, okay, we are under DDoS, our students, they cannot register anymore, they cannot do the online training or whatever. Then an incident response team like us, for instance, the school, they have their dedicated incident response team, they take some actions. And then they see, for instance, okay, there is this video camera that is a set of video cameras that is sending us a lot of traffic. And then what happened then is the internet response teams, they could then contact the internet service providers or the upstream providers and say, hey, there are in your network, there are 3 video cameras, for instance, and these 3 video cameras are, for instance, that these are from your manufacturing plant. And then what the internet service provider says, okay, we will null route this traffic. So they will disconnect, they will cut the connectivity of your camera. So then what you will see, for instance, in this case, your camera will be not accessible. But your camera is not accessible because it's under DDoS, but it's not accessible because the internet service provider cut the connectivity because your camera contributed in a denial of service attack against someone else. And this is quite often the case. Then what happens also, it's if you have some vulnerable devices, then there are some amplification attacks. So that means that if you're vulnerable, and how does it work? So the attacker, he spoofs the address of the victim he wants to address, and then he sends to your service, for instance, to your DNS server, to your NTP server, he sends some requests, and but with the address of the victim he wants to attack. And as his request is smaller, your server will then reply a larger response to the victim, and then overwhelm the resources of the victim. Then, of course, what could then also happen, it's that afterwards internet service provider block connectivity, and afterwards your DNS server is not available anymore, or your NTP server is cut or something like that. So that's why it's good to have also an eye on it to not contribute in denial of service attacks against other people. And so what are the effects of the denial of service attack? So normally what you see, it's often you see, okay, there is a service disruption. So for instance, your systems are unavailable. So for instance, if your router to access your OT network is compromised, and it's contributing in a DDoS attack against school, for instance, then afterwards you cannot reach your OT network anymore. And then what could happen as well, it's there is also a business impact. So because if your website is down, if your systems that you have on a different plant cannot send any telemetry anymore to another plant, because to the main plant, because the DSL line is saturated, then afterwards, yeah, you will have maybe also some production outages due to that. Then you have you have also a customer impact, because afterwards, when customers are relying on your infrastructure, then yeah, you will have that, and then the collateral damage. Okay, this one I explained already. You can get some reputation damage, and yeah, afterwards you have to restore the services. Maybe you have to pay SLA penalties, so it will increase also the cost. And then what is also important is to distinguish between denial of service attacks and, for instance, misconfigurations. So many attacks that are reported to us, so the internet service provider, so the victims, what they say is, we have a DDoS attack because our production system is not accessible anymore. But then we noticed that, for instance, okay, there is a switch at the upstream provider that broke down, and for instance, failover didn't work, and so that's why your service is down. So that's why it's really essential, if you face these consequences of denial of service attacks, that you have the data such that you can verify it. So for instance, if the switch is from your upstream provider is down, if a failover failed or something like that, you can see it in the data, and then you know then, okay, it makes no sense to prepare the other measures that I will present later. Yeah, and then what we see also a lot is misconfigured systems, especially where it's very hard, it's when you have redundancy, because then maybe in some constellation it works, and then there are some tiny changes in the constellation, and then your redundancy is not working, and yeah, it's faced, and then some victims think they have denial of service attack. But to find this, you need really data, network packet captures, or log files to differentiate between these cases. Here is just an example, for instance, of misconfigured systems. So this happens all the time. Even if you have the best procedure ever, misconfiguration happen all the time. So the best thing is to see it, is you do also traffic. If you record the traffic and then you analyze it in peacetime when you do it, so then you can, for instance, discover these attacks. So here you see it's a packet capture. So you have here the timestamp initially, so the 24th of September, then the time at 12:13. There is the source IP address that is sending you something, the source port. The destination IP, we had to blur it because this is the network owner wanted it like this. And then you have the different, you have the traffic, the protocol that it is. For instance, here, it is a DNS request to time.windows.com. So that means that on this laptop, there was, or laptop or Windows server, we don't know what it was. You had some, you have two DNS resolvers that are configured. Everything is working because the first, from the user perspective, but how is this happening? Once you have the resolver A and the resolver B that is configured, the resolver A, it's sending the packets to the wrong IP, so that's why it landed in our black hole network. And the resolver B, it's and then it automatically switched to the resolver B. And then the user doesn't notice it because the resolver B is working. Now your system administrators, they are doing an upgrade or maintenance on the resolver B. They say, okay, we have resolver A and B configured on all the machines, so we have redundancy, and they reboot or they shut down the resolver B, and then suddenly your Windows server cannot reach DNS anymore because it wants to send to resolver A, but resolver A is badly configured. And then afterwards you have an outage because your server cannot access the other servers anymore. And then, and then you could see it, for instance, oh, there is a DDoS attack because the server is not reachable anymore, but it's not a DDoS. So that's why it's really essential then to look in the data and then to see, okay, there is a misconfiguration, and then you can then fix it. And then what we see is also here is another example where denial of service victims, where they how this happens. So, for instance, there is so here is also a packet capture, an output of an interpreted packet capture. So we have the timestamp. So it was 2 days ago, a bit, around 1 o'clock in the night. So, and then you had some. So what happened here is you see the reply of the web server that is under attack. So why do we see that this is a web server? Because it has the port 443, and and then if you do a lookup, so you can then find maybe which web server it is. And what happened there is the attacker, he spoofed our IP addresses and then sent some requests to this web server. And the web server, he just see, or for instance, whatever server, he just see IP addresses that are coming in and then has to reply to it. And to reply to it, it has to maintain a connection table. And in case spoofed IPs are not filtered, then the table, the connection table on the server will be filled up. And when it's full, it's like if you have the queue for the bakery, if it's full, then no legitimate customer can enter anymore the bakery because the queue is full. And this happens all the time. So within 5 minutes, we observed more than 800 different attacks. So you see constantly attacks that are ongoing. So the highest risk that you have, for instance, in the manufacturing sector, is that your infrastructure, especially if it's distributed over multiple sites, that some parts, for instance, routers, they are compromised and abused to participate in denial of service attacks against someone else. So here you see, for instance, an example of when of an attacker group that is even going further. So when they identify, so they were looking for instance, for some attacker groups are looking for having equipment for denial of service attack, but then afterwards, if they can go further and then even they can compromise the infrastructure further and then sell it to other attacker groups. For instance, here is an access that was given to another attacker group that is compromising some OT equipment, but for political reasons mainly. So the last part is mainly about incident management part. So what is really what we see sometimes it's when there is an ongoing denial of service attack, and you have the technical teams that have to do the data collection, that have to do the data analysis to see exactly what it is it a DDoS, it's a false positive, etc. But then afterwards, you have then also the high management, the stakeholders, they want to have some information on the DDoS. So and afterwards, then the technical teams. So you should give them enough of time to do their analysis, although it's complicated. But the technical, the technical data, it's really essential to know what kind of attack if it is an attack, what kind of attack it is. So what happens there? It's the best is if you have someone in the technical team that is just doing there and taking all the notes, noting down what happened when, passively, and then this person then is has in the lead. He has and then this person is then also doing the reporting, the reporting, etc. Then what we observed also a lot is the denial of service attack is not just a technical issue, because sometimes if you are, for instance, working for a critical infrastructure, then it could happen that afterwards a regulator intervene, because then you are regulated by some regulators, or sometimes you can have some requests from the press, from the parliament, etc. So and then you are busy already with your DDoS, and then you have again the communication. This is communication to do. So so the more you can prepare, the better it is. So then on the other hand, when you have denial of service attack, if you have a distributed production plant, so you are dependent on your service providers, for instance, on your ISP, etc. So then the best is when you have the DDoS attack, and then when you contact your ISP, hey, can you help us? Then the best is, okay, you should prepare as much as possible in advance to make this smooth. And then you have afterwards, when you have the incident is done, then the best is also to clearly identify the lessons learned and what you can do best. But what we also observed a lot is if the rules were not clear. So at some point in time, the technical team, they had to write some communication part and stuff like that. So this is also not good. So you have to clarify the rules and who takes the decisions, what will be done in advance and not during the denial of service attack. So when you have a denial of service attack, it could happen that all your infrastructure is not available. So that's why it's important also to have an out-of-band communication plan. So, for instance, and where you have a contact list of people and vendors that you can call. For instance, if your fully network infrastructure is under DDoS and you cannot reach your telephony system anymore, then you need to have and your document server is also not available anymore, then the best is to have the contact list on the paper with mobile phones, so where you can call your people, or with radio if you want to have radio. Then what you can this is really important, and also with the ISP you can check what you can do. Then what is also important, when you have the DDoS and you start to look at your network traffic and you have never seen it before, then it's very hard to distinguish what is this now normal, or is this the attacker traffic, or is the other one? So this is very important, even in peacetime, to do packet capture and to review it. Yeah. Then for instance, for the communication, for instance, when you have a press communication, it's really a good practice is to prepare communication plans in advance. So for instance, where we say, okay, we have a denial of service attack, our technical teams are working on it. So some communications like this, also some status pages that you have, for instance, on Twitter or on other websites outside your infrastructure where you have a status page. If everything is okay, if you are not available, yeah, with some. This is something that you can prepare as well. Then, what could happen? Normally, the attacker groups, they are for DDoS, they are attacking low-hanging fruits. So that means that if, in case of your own network, you have your network, and then in your network you have the IT systems, but you have also the OT systems that is using this capacity to interconnect with the second site. So maybe you can foresee to, for instance, to host some IT services completely somewhere else, because if the network is fully saturated, then at least it's not impacting your OT systems anymore. Yeah, what is when an DDoS is experienced, for instance, it's very important that you have either internally technical people or you can rely on external people that could do in a quick way a verification if it has if it's in denial of service attack or an outage. And if it's a denial of service attack, you can already have some you can prepare already some mitigation services with a lot of internet service providers. They are offering that so that they can help you. And for instance, what they offer a lot is scrubbing and filtering and stuff like that. And then afterwards, what is also important is that during the incident, at least you can take some samples of the traffic that can then be used for afterwards for the forensic case afterwards when the DDoS is over, that you can then see what was happening. For the communication, yeah, the best is the more you can prepare for the communication, the better it is. For instance, the status updates, press and social media. Then often when you are in OT, sometimes you are regulated by some regulators, for instance, in NIS2. Where you have to do some reporting to the different regulators. So this is also something where you can prepare as much as possible in advance. And then what is also important is that you have a channel to communicate with your customers and partners. For instance, when you have an outage, that you can tell quickly to your partners, hey, we have an outage or denial of service attack. We are working on it. And then for real critical parts, you can think about to have some alternative access methods. If, for instance, if your DSL line is saturated, completely saturated, that you have some other ways to access your OT systems. And then what is also important is to have a single source of truth, so that you have, so especially if you are a large organization, that you have, so that you have one status page and not multiple ones, that you forget. That could, if some team didn't update one, then it could lead to some confusion. After the DDoS is over, what we recommend is really to search for the root cause. Why did this happen? Why were the attackers successful? And then improve either your infrastructure, or you can then create an incident playbook, so to train the teams that they can be better prepared for that. And during incidents, normally there's a lot of stress because the real production is impacted. So the more these incident response actions are drilled, the better it is, because then the people are doing this kind of movements automatic. So to conclude this presentation, so what is really important is to have when you have if you want to protect against denial of service attacks, that you have an accurate inventory of the machines that are publicly accessible, because normally through the public available machines, these are the machines that are attacked normally for the denial of service attacks, because they can be reached by all the different kinds of bots. Then, as in peacetime, so when there is no DDoS ongoing, so we really recommend to have someone or some external services that are doing network, that record all the traffic, that machine-to-machine communication, and such that afterwards the team that has to do the technical analysis during the incident is able to see, okay, this is legitimate traffic or this is not legitimate traffic. And then, then also you have to foresee for the team to have the additional resources. So either the team, the persons, or even the devices for doing this kind of evidence collection. And then, of course, we have the dedicated NGSOT training, for instance, where you can do the training infrastructure, where you can, for instance, that you can use, for instance, if you want to train your personnel how to do network traffic analysis, because this is a black hole network, honeypot network. So this is, this infrastructure can be used for learning this kind of traffic analysis. So yeah, this one was mainly it. So now I'm willing to reply to all the questions.
Thank you very much, Gerard, for this insightful presentation. Yes, there was a question in the question tab. Apparently, your website was down for a while, but I think this problem is fixed. Like on my side, the website works perfectly fine. But yes, like I would say like that now is the time to ask your questions. You have two experts here, and cybersecurity is a topic that is often underestimated. So it would be nice to see that you use your chance to ask as many questions that you can. Now you can also in the information tab beside the chats, there is also the LinkedIn profile of our two speakers from today. And I also wanted to say a big thank you to our two speakers and to our participants for joining today. I'm really happy. And if, in case there is no more question, you can always visit our event page by scanning the QR code or simply going to DIH.lu. Our next webinar is on the October 10th. It's DDIH Talks episode 13. We will talk about AI, a technical sandbox. Next workshop is a Test Before Invest workshop on October 2nd on predictive maintenance. And this will be held at LIST, the Luxembourg Institute of Science and Technology. So don't hesitate to contact our two speakers, as I said in the information tab besides the chat. And I wish you a wonderful day and thank you for joining. Bye.
Thank you. Bye-bye.